Alright, today we're going over Module 8 homework problems. This is for question number 8. The accompanying table shows the ages and years of 11 children and the number of words in their vocabulary. So I'm thinking the older the children become, the more words they will know. So I'm thinking it should be like a positive correlation. It should go up from left to right. Well, look at how crazy this first graph is. Look at the ages. The horizontal axis is ages, and we're talking about children here, right? It's going up by 500. 500-year-old child, 1,000. No, that's not it. So A is out. A is out because the scale is just ridiculous. 500, 1,000, 1,500 years of age. So A is not it. What about this one? This could be it. 1, 2, 3, 4, 5, 6, 7, 8. It's going up from left to right, I can see. So B could be it. And I'm looking at C2. C shouldn't be it, right? Look at the ages. 500 years, 1,000-year-old. These are not ages of children, right? So that's not it. What about D? And D's going down from left to right. So, I think the answer is B. Why? B is the one with the right scale on the horizontal axis, and B is the only graph that's going up from left to right. But if I want to actually find the scatter plot, this is how you can find the scatter plot, okay? So just send it to your StatCrunch. Let's see if I was logged in. No, of course I'm not. All right, let me go and see if I can sign right here. If you just look at the scales, you can eliminate a couple of these wrong choices. All right, let's try again. Okay, so take a look. This is how you can make a scatter plot, okay? Go to graph, go down to scatter plot, put the x variable to be age, y variable to be vocabulary size, and you just go ahead and click compute. Ta-da! It's definitely going up from left to right. So our answer, B, is correct. So that's how you can make a scatter plot using StatCrunch. Oh, now they want us to find sample correlation coefficient R. We talked about how to find these values, but let's try one more time, okay? So what you're going to do is, and there's two ways to do this, okay? If you just want to find correlation coefficient, you can go to Stat, Summary Stat, and click on Correlation, okay? Tell them that you want the correlation between ages and vocabulary size, and you have to click on both of them. So on my, what did I use, the shift key? Yes, so I use the shift key or the command key. So make sure to select both and just click on compute, and ta-da, here is the correlation, okay? Round to 3 decimal places, so I'll go ahead and round the last number up to 9. And we can tell them because that R is positive, right? That's a positive number. There is a positive. And 0.979, that's very close to 1, right? We would say that is a very strong positive correlation. And if you're wondering what's considered positive, what's considered perfect, well, the perfect positive will be a perfect 1. If R comes out to be 1, exactly 1, then we say it's a perfect positive correlation, but it's not quite 1 yet, it's 0.979. So we would say that is still strong positive correlation. So we shouldn't say age and causes though, because just because two things are correlated does not mean one thing caused the other. So as age increases, the number of words in children vocabulary tends to increase. That's all I can conclude about this. But I shouldn't say aging causes the number of words in children vocabulary to increase or decrease. We shouldn't say this thing causes the other. All right. Use the table of critical value for the Pearson correlation coefficient to make a conclusion about the correlation coefficient alpha equals 0.01. You need to open up this table now, okay? You need to open up this table. Now, what was the sample size? Remember they said they looked at 11 children, right? So on n equals 11, on this row right here, and they did just say use alpha level 0.01. Look at this decimal, 0.735. You have to compare your R to this 0.735. And I'm going with this number because we have 11 children in the sample, and the alpha level they want is 0.01. So that's why I'm looking at 0.735, okay? So let's compare these, 0.735. The critical value is 0.735. Therefore, there is sufficient evidence at 1% level of significance to conclude there is significant linear correlation between children's ages and number of words in their vocabulary. And we say this because the R value, 0.979, was greater than this critical value. Anytime the correlation coefficient R is greater than this critical value that you read off from the table, then there is sufficient evidence to say that there is a significant linear correlation. Okay? If the number is smaller, then we're going to have to say there's not sufficient evidence. Okay? So that's it for question number 8 on module 8 homework.